welcome to ScientiFacts. In this video, we'll be discussing more the weight of an object on the moon. We know that the weight of an object on the Earth is the force with which the Earth attracts the object. Similarly, the weight of an object on the moon is the force with which the moon attracts the object. The mass of the moon is less than that of the Earth. So it makes sense that due to this, the moon exerts a lesser force of attraction on the objects. Note: the formula to calculate the weight of an object is the product of mass and acceleration due to gravity, which is denoted by small g. Therefore, it is W equal to mg, where W denotes the weight, m denotes the mass, and g denotes the acceleration due to gravity. So this is a picture showing the mass of the same person on different planets as well as the weight. We will derive the weight of the ratio of the weight of a person or an object in the moon to the Earth in this video in the later part. Conclusion from the picture. We can calculate the value of g on the moon from this picture. It is 1.625 meter per second square. But how did we calculate it? We all know that W equal to mg, as we just saw over here, W equal to mg. So 200 Newton, they have already given the weight in this picture, equal to 120 kg. Mass also they have given into g. G is the acceleration due to gravity, which they have not given. So to find g, we need to, so if we transpose the terms, it will become g equal to W by m. So therefore it will be 200 Newton by 120 kg is 1.625 meter per second square. So that will be the value of g on the moon. You can notice that it's just 1/6 of it than that of the Earth. Ours is 9.8 meter per second square. Derivation of the ratio of the weight of the moon to that of the Earth. So we'll see the difference between now. If we take the same object, we'll see the difference of the weight of the object on the moon and that of the Earth. Let the mass of an object be m. Can be any object. Let the weight on the moon be Wm. Wm because weight on the moon. This small m is, denotes the moon. Let the mass of the moon be m. And this is the mass of the moon. Again, m denotes the moon, small m. And its radius be r, which is of the moon. Again, by applying the universal law of gravitation, the weight of the object on the moon will be Wm equal to gmm into m by r square m. So basically it's confusing the here. So W, the weight of the moon, is equal to gravitational constant into the mass of the moon into m. This m denotes the mass of any object by r square of the moon. Let the weight of the same object on the moon be W. This is WE, so it denotes the weight of an object on the Earth. The mass of the Earth is m and its radius is r. So remember this. So the mass of the Earth is 5.98 into 10 to the power 24 kg. And its radius is 6.37 into 10 to the power 6 meters. Whereas the mass of the moon is 7.36 into 10 to the power 22 kg. And its radius is 1.74 into 10 to the power 6 meters. So over here, the weight on the Earth is equal to, how do we calculate the weight on the Earth? So weight on the Earth is equal to the gravitational constant into the mass of the Earth into the mass of the random object by r square. When we substitute the values we get, so this is weight on the moon is equal to gravitational constant into 7.36 into 10 to the power 22 kg into the mass of the random object divided by 1.74 into 10 to the power 6 meter whole square. This is the radius. So we use this formula to do it and just substitute the values and find it. So after using this formula respectively to find the weight of the moon and weight of the earth, we get the weight of the moon as 2.431 into 10 to the power 10 g into m. As we saw, this thing and this thing is remaining. So we just divide this by this respectively for both and just multiply g into m in the last, like this. After we get this and divide it by this, we just get this and just multiply g into m. So weight of the moon, we get it as 2.431 into 10 to the power 10 g, capital G into the mass of the random object. WE is equal to 1.474 into 10 to the power 11 capital G into mass of the random object. Dividing. So when we divide the weight of the moon by the weight of the earth, which is equal to 2.431 into 10 to the power 10 g into m by 1.474 into 10 to the power 11 g into m. So we get it as, so we get the answer as 0.165. Actually we get the answer as 1.65 if we just divide this by this, but since it's 10 to the power 11, we need to just divide that 1.65 into 10, which will become 0.165. So 0.165 is equal to 1 by 6. So therefore, the weight of the object on the moon divided by the weight of the object on the earth is 1 by 6. So therefore, the weight of the object on the moon is 1/6 of the weight of the object on the earth. So therefore, for example, if the weight of an object is 36 Newton on the earth, the weight of the object on the moon will become 6 Newton. Example 1. The mass of an object is 10 kg. What is its weight on the earth? This is very easy. Mass, we need to write what's given as usual. So mass, which is denoted by m, is equal to 10 kg. They've given it in the question. Acceleration due to gravity, which is denoted by small g. We all know it has 9.8 meter per second square on earth. And we need to find the weight. This is a direct question. We don't need to transpose also. So W equal to mg, we just need to multiply the mass into the gravitational acceleration due to gravity. So W equal to 10 kg into 9.8 meter per second square. This is 98 Newton. Newton is the SI unit of weight. Thus the weight of the object on earth is 98 Newton if its mass is 10 kg. Example 2. An object weighs 10 Newton when measured on the surface of the earth. What would be its weight on the moon? We clearly know that the weight of the object on the moon is 1/6 of its weight on the earth. We just saw it while deriving the weight compared to weight of an object compared on the moon and compared on the earth. So therefore, it's 1/6 of the weight on the earth. So that is W, the weight of the moon, weight of the object on the moon is equal to weight of the object on the earth by 6, which is 10 by 6 Newton. So that's 1.67 Newton. That will be the weight of the object on the moon if it weighs 10 Newton on the surface of the earth. Yes, basically you just need to divide 10 by 6, which is 1.67. Thus, the weight of the object on the surface of the moon would be 1.67 Newton. Hence, we conclude the session with this. Don't forget to leave your video idea. Thank you.